Good morning, chemistry students. This is Mrs. Kremschreider, and we are going to look at our Chapter 4, Day 2 notes. So we're going to finish up Chapter 4 today. We're continuing with using our conversion factors, which remember are those ratio of equivalent measurements, and dimensional analysis, which is where we're looking at our units and treating them like they're algebraic letters and making sure that they cross out to solve our problems. So today we're going to kind of take a look at what are considered perhaps to be a little bit more complex problems, okay, because they are multi-step problems. So a suggestion to solve these problems is to break them down into smaller, manageable parts. And for these problems, it is often necessary to use more than one conversion factor. And we actually saw a couple examples of those already yesterday when we did our notes. When we're going to be, some of these problems are going to require you to convert more complex units, in which case you're going to tackle or approach each unit separately. And one of the things that's nice about that is because when you're multiplying and dividing, the order doesn't matter. It doesn't matter which unit you choose to tackle first. You can tackle a unit first, and your friend could tackle a different unit first. You'll still end up with the same answer at the end. So we're actually just going to look at two example problems today. So our first example problem is we want to look at the density of manganese, which is 7.21 grams per centimeter cubed. We want to know what manganese's density is in kilograms per meter cubed. Okay, so again, we might still need that metric system. So again, I'll go ahead and put that over here. Okay. So again, this is kind of considered that more complex unit problem because notice I need to convert grams to kilograms, and I also need to change cubic centimeters to cubic meters. Okay, so I have to change both of those. And the order that I do that, it really truly doesn't matter. What is important is that when I start this problem, I know which unit's in the numerator and which unit's in the denominator. So although I write it here kind of grams per this way, when I write it over down here to start my problem, I clearly want grams in the numerator and cubic centimeters in the denominator. It doesn't matter which one we do. Grams and kilograms is a little bit more straightforward, so let's do that one first. So grams are in the numerator, so they have to go in the denominator, and kilograms are going to go in the numerator. Okay, and even if I want, I can fill in my numbers for this right now. That's fine. Kilograms is larger, so it's 1, and 1, 2, 3. Okay, so 1 and 3 zeros, 1,000, or 10 to the third. Okay, now if I stopped right now, my units would be kilograms per cubic centimeter. Notice I want kilograms per cubic meter, so I have to convert centimeters, okay, are going to go on the top because they're in the bottom, and I'm going to change them to meters. Now, notice I purposely didn't put a cube here, and here's why. I don't know a relationship between cubic meters and cubic centimeters, but I do between meters and centimeters. So I'm going to use that and kind of show you a trick of how to fix this, okay? So I'm going to look for my relationship, and again, meter is larger because it's my base, and it's 2 moves, so it's 100 centimeters. But, right, this is cubed. So how do I fix that? I'm going to cube this. I put my cube outside my parentheses. Now, I can distribute that, right? I think that's the right math term, where I bring that all and to everything inside my parentheses, which means this becomes 100 cubed, centimeters cubed, 1 cubed, and meters cubed, and now I can disregard, and I've brought that cube inside. So now I have cubic centimeters crossing out, and I'm left with units of kilograms per cubic meter, which is exactly what I want. So now I just have to do the math. Now I do need to be careful, right? Because I have to take 100 and I need to cube it, right? So be very careful when you do this, that you cube it. And then you have to divide it by the 1,000 that's in the denominator, okay? And so you should get 7,210, okay, kilograms per meter cubed. Okay, so to kind of help you a little bit about how did I put that in my calculator, I put that in my calculator as 7.21 times, okay, 100 caret 3. Okay, and then I hit my enter. Okay. Now, with your calculators, most of them, if you just then go ahead and divide, you're going to get the word answer. So it means that it just took what your answer was, divide by 1,000, and I hit my enter again. And that's how I got 7,210, which is the correct answer. So it is important that you know how to use your calculator, okay? And I really would prefer you use your calculator because hopefully after Christmas break, we're going to be back face to face at least some of the time. And if by chance you have a test or quiz to take during class time, I'm not going to allow you to use your cell phone as a calculator. So please, please, please invest in the $12 TI 30X calculator so you have a calculator to use. So that's our first problem. Our second problem that we're going to look at is this one. There are 7.0 times 10 to the 6th red blood cells in 1.0 millimeter cubed of blood. How many red blood cells are in 1.0 liters of blood? So, like I said, pretty much all of the problems you're going to do are story problems. This problem is really asking me, in 1 liter of blood, how many red blood cells do I have? this information here, okay, this is given so that I have a conversion factor, but it's not what I'm going to start with in my problem. So I'm going to start with my 1 liter, okay. I'm going to convert liters to milliliters, because remember, I know something about a milliliter and a cubic centimeter. Right, so I have liters crossed out. I have milliliters crossed out. I'm in cubic centimeters. Now, to use this, I need millimeters cubed. So I'm going to kind of do like I did in that last problem we just did. I know something about centimeters. I know something about millimeters, and then I'm going to end up cubing it. Okay, so we can go ahead and fill in these numbers so far, right? And again, that metric system, a liter is larger, and it's 3 moves, so it's 1,000 milliliters. A cubic centimeter and a milliliter are the same, so it's 1 to 1. And again, a centimeter is larger, and there's 10 millimeters. And then again, I'm going to bring this 3 inside, so it's 10 cubed, millimeters cubed, 1 cubed, centimeters cubed. And now I can get rid of that cube that was there. So now, right, I am in millimeters cubed. I'm trying to get to red blood cells, but now I can use this information that they've given me, right? Millimeters cubed have to go on the bottom. Red blood cells are going to go on the top. And it told me that there are 7.0 times 10 to the 6th red blood cells in 1.0 millimeters cubed of blood. So now notice that the units I'm left with are red blood cells. Again, remember, I'm going to multiply by these numbers because they're in the numerator. And I am going to have to divide by these numbers, but 1 cubed, remember, is still 1 and 1. So realistically, I don't have to do any division to get this problem on my calculator. Okay, so how am I going to type this in my calculator? I'm going to type 1 times 1,000 times 10 cubed times 7E6. And then I'm going to hit my enter. And your calculator should give you an answer of 7 point, and again, we should have, notice here, 2 sig figs. This is a definition and has unlimited. This is a definition, has unlimited. This is a definition and has unlimited significant figures, so none of those are going to limit my significant figures. And notice this also has 2 significant figures. So my answer should have 2 significant figures, so I need to write it as 7.0 times 10 to the 12th red blood cells. So that's a couple examples of those more complex units. Your homework is on page 95. I'd like you to do questions 15, 16, and 19. And on page 100, questions 28 and 29. You do need to show all your work. Okay, like this one here, like this one here. Okay, so I want to see all your work on your paper. Again, my preference, you need to handwrite this no matter what. I don't want you to waste time trying to type this up. It's a waste of your time. Use that time to do something else fun. Use that time to do some Christmas shopping for your family. I don't care, but do something fun. Do not spend it typing up your chemistry homework, okay? I want you just to handwrite this out. My preference is you try that Adobe. I think I spelled that wrong. Adobe Scan app, because honestly, that is much easier for me to read than when you take a picture. If for some reason you don't have a smartphone, that app, remember, was free. If for some reason you don't have a smartphone or it doesn't work for some reason on your phone, then a picture's okay. But make sure the picture is easy to read, and then you're going to submit it for the assignment in Google Classroom. Now, again, I will be making a key for this assignment with all of the work shown the way that your work should be shown. Okay, so you do need to remember, I'm not going to check your work. I'm going to glance at it and see that you showed your work. Okay, but I'm not going to specifically check whether or not you set up your work correctly. I'm going to expect you to use that key for the homework assignment and check your work. Have a great day. I will talk to you tomorrow.